Hi everyone. We are going for today we are going to I am going to give an overview on my project prediction of energy consumption for household. What is energy? Energy is what we are consuming everyday life. Energy is calculated by the power consumption. Today the energy is playing a very important part in our lives as appliances, gadgets, electronic appliances, everything is increasing. With their increase, their usage is also increases in their household. So the power consumption, so the bills of our houses and the greenhouse gas emission is also increasing. So energy consumption in our household depends upon the various factors such as occupancy. What is occupancy? The number of people living in our houses, their behavior, their lifestyles. It all depends what we consume, energy consumption. It all depends on these factors. In this project, I am going to predict the energy of household taking weather conditions, as weather plays a vital part in our energy consumption. For example, in summers, we are using AC and fan, both the appliances. But in winters, there are less use of electronic appliances as compared to the summers. So our bills also increases, greenhouse also gas emission also increases. The basic purpose of this project is to provide the knowledge or the prediction to the energy suppliers who are providing the electricity in our homes. It will help them to predict the next day energy, next day power which the houses will be need to operate. Why I have taken this kind of topic, like the increasing urbanization, our dependencies on the electronic gadgets or appliances have been increased. It is directly affecting our environment and the bills are also increasing of our home. So there comes the need of predicting energy consumption. How we can predict this energy consumption? Actually, this energy is depending upon the power. We are utilizing the power that is in kilowatts. Energy is calculated by power into time, that is the power we consume at that particular time. What will this problem will help to reduce it? It will help the occupants to reduce their energy consumption based on the previous day. For example, there are three persons in our home. Three-person in a home, they are sitting in different rooms, so the energy use will be also more. But how can they reduce it? They'll be able to know that this much power they have consumed today, that is in 24 hours they have consumed this much power. So they'll calculate the energy consumed by them, that is power into time, and will be getting the energy consumption, and that will be also helping this energy consumption for the energy suppliers also. What are the main objectives of this? To understand the impact of different factors such as climate, occupants, and their behavior, their lifestyles. To predict the value of energy consumption by total power utilization of home. What does it mean? That I'll be calculating the total power of all the appliances for that particular day, like fan, AC, refrigerator. They are consuming some power in every interval of time. By calculating that total power, I'll be predicting the next day energy power consumption. Then finding the best model for power consumption. Then calculating the energy consumption based on the value of power consumption by using regression model. This is the workflow or architecture I am following it. First of all, home appliances, then data collection and the retrieval will be done. Then data wrangling and analysis. What is wrangling? Wrangling means to split the columns. It's like a data pre-processing, another term for data pre-processing, splitting the column, combining the column, merging the column. Data importance, then model selection, then testing and training, predictor, validate and evaluation parameters. This is first of all data analysis of the home appliances from where I have calculated the total power consumption. You can see the bedroom outlets, this red line is consuming in monthly power, it's consuming the most power of the house. Most of the power are consumed by bedroom outlets. This is the total power of a 1 year. In this we can see that July and August is predicting is consuming the most power of our houses. So what we can do to reduce this thing, that in July and August we came to know that this is a power consumption of our house. So in the next month the power consumption got reduced by automatically predicting, sorry, not by automatically, by model predicting this thing. This is the graph. This is the analysis of 5 days data consumption, power consumption at various time intervals. This is the feature importance I have done. This is done by Borta package. Borta package. This is different. This condition is, this algorithm is different from REF algorithm which we traditionally algorithm which we follow. This package, this is a package in R where we this iterate and it check the importance of variable with another variable with iterations, and it gives us whether it is important, unimportant or not important. It predict the the importance with every other variables at any time of interval. It will say it is important whether in any condition it predicted. But REF it only predict once. If it's not important, it leaves it. This is the what the prediction I have done. This prediction has been made actual versus for random forest and neural networks. Here we see that in the scatter graph there are lots of points together. So this means in a prediction, actual and predicted are almost they are same values. They are coming around closely, they are related to each other. So our model is quite highly accurate, the model which we have made. That means our predictions are good. Similarly, these are the evaluation parameters I have used. This is R, R square, RMSE. R is correlation coefficient, R square coefficient of determination, RMSE root mean square error. Less the root mean square error, more is the good our model is. More good our model is. So in this we see that the minimum root error is in decision tree. So the prediction is good with the decision tree. Cross validation I have done. Cross validation was done on decision tree model. It cross validates our actual and predicted data. The model we trained, then again we split it into K5. I have taken here a K5 cross validation factor. It will iterate again and again, and this actual and predicted values are calculated. When we see the difference between these two, it is less than 1. So our trained model was really accurate one. Prediction. Here I have predicted the power consumption. In this table, the power consumption is predicted from the trained models, because trained models was having the target value as total power, because the data set which is given in this is of Huma's trace energy data set. It was having a different appliances. I have used the home A appliances with the weather conditions. This is the prediction on this date. This was predicted on this date. So prediction and actual values, they are having very less difference. So our model has been we can say our model is good in predicting the values for next day. This is the regression of the energy by day. Here I will have first of calculated the energy. How I have calculated the energy, I have already told it's power into time. Energy is calculated, linear regression algorithm was performed in it. It has got the mean at 95% and confidence interval with 95%. Here we see that root mean square error is 0.547. We have got it here. Here we see blue dots, it's around mean almost, and it's deviating from it. So it's that a prediction is good enough to predict the next day energy consumption. Now what's the conclusion we got it from all this? Why we are doing this energy consumption, why it is important, is it necessary to do it, so and so. So predicting the energy consumption is very important for energy management. We see that some climatic changes, even in last few days it was so climatic, it was so smoky that the people were not able to breathe. It's due to some human factors also, or because of greenhouse gas emission also. Greenhouse gas emission is with the industries because of household appliances. So it's important to get the good energy prediction, and every house, every occupant in the house is responsible for its own climatic conditions. So the data used in this for energy consumption is taken with weather. It has been concluded and predicted by calculating the power consumption of previous days. So predicted energy consumption can help the energy suppliers to estimate the supply that will be required by the household next day. So it's important because it will be helping the energy suppliers to provide the electricity in our homes also, and it will help the occupants also to reduce their bills and greenhouse gas emissions. Thank you.